The nucleus is made up of protons and neutrons. Protons and neutrons are called nucleons. When two protons are brought close to each other, what kind of force will the protons experience? The protons are of the same charge. Thus, when they are brought near to each other, they will experience a repulsive force. The repulsive force will tend to push the protons away from each other. Then how come the protons in a nucleus do not move apart due to this repulsive force? There is another force that acts on the nucleons. The force is called strong force. The strong force holds the nucleons together. It is a short-ranged force because it only acts on the nucleons that are very close to each other. The strong force holds together 1. Protons, 2. Neutrons, and 3. Protons and neutrons. When two protons are close to each other, they experience a repulsive force that pushes them apart. At the same time, the strong force also acts on the protons when they are very close to each other. The strong force is greater than the repulsive force. Thus, this force binds the neutrons and the protons together. Identify the number of protons and neutrons in the nuclei shown. Elements with small nuclei have protons and neutrons very close to each other. Hence, the short-ranged, strong force can easily overcome the repulsive force between the protons. Thus, the nucleus is stable. However, nuclei of heavy elements, which have a large number of protons and neutrons, are unstable. Why? The strong force only binds side-by-side protons, like protons A and B. The larger the distance between the protons, the weaker is the strong force. The repulsive force between protons acts over a long range. It will exist between many pairs of protons, like A and B, A and C, and even B and C. Hence, for protons which are far apart, like those on opposite edges of a large nucleus, the force that binds the two protons is weak compared to the repulsive force. Thus, the larger nucleus is less stable than the smaller nucleus. Radioactivity is the spontaneous splitting or disintegration of an unstable nucleus with the emission of particles or energy to become stable. This process is also known as radioactive decay. There are 3 types of radioactive emissions. 1. Alpha particle, 2. Beta particle, and 3. Gamma rays. Click on each radioactive emission to find out more about the decays. In an alpha decay, the nucleus emits an alpha particle. An alpha particle is a helium nucleus made up of 2 protons and 2 neutrons. In a beta decay, the nucleus emits a beta particle. A beta particle is a fast-moving electron. In gamma decay, the nucleus emits gamma rays. Gamma rays are high-frequency electromagnetic waves.